let's do C. It is further given that point F is a point on the first quadrant, so that FEDA, you see the FEDA is a parallelogram. Then what do we know about a parallelogram? The opposite sides are equal and parallel. The coordinates of D, 8, 3 are also given. So now we have the coordinates of D. Determine the coordinates of F. How can you find the coordinates of F? So if this is a parallelogram, so we can find the midpoint of EA or AE, which will be here, right? And then remember, the diagonals of a parallelogram bisect each other. So it means this is the midpoint of the diagonal. So we'll have the diagonals here. Okay, so we can find the midpoint of AE, and then using the coordinates of D and the coordinates of the midpoint of AE, we can find the coordinates of F using the midpoint formula. Okay, but first of all, we have to find the coordinates of E, the midpoint of AC, and then after that we find the coordinates of the midpoint of AE. Let's start by finding the coordinates of E, the midpoint of AC. So we're saying x at A plus x at C over 2. That is these are the coordinates of E. And then y at A plus y at C divided by 2. So it's going to be E, and then 4 plus 6 divided by 2, and then 1 plus 7 divided by 2. Alright, and then what we get? We'll get that E is 5, 4. These are the coordinates of E. Now we need to find the midpoint of AE. It will be x at A, which is 4, plus x at E, which is 5, divided by 2, and then y at A, which is 1, plus y at E, which is 4, divided by 2. And then midpoint of AE is 9 over 2, and then 5 over 2. These are the coordinates of the midpoint of AE. So now, using the midpoint formula, we can find the coordinates of F, just using the same formula as this, right? So now we know the midpoints. Okay, 9 over 2 for the x coordinate, 5 over 2 for the y coordinate. X at D plus x at F over 2 is equal to 9 over 2. And then y at D plus y at F divided by 2 is equal to 5 over 2. Right, x at D is 8, and then plus x at F over 2 is equal to 9 over 2. Alright, and then we can multiply by 2 on both sides of the equation. So it becomes 8 plus x at F is equal to 9. And then we can subtract 8 from both sides of the equation. X at F is equal to 1. Alright, and then this side, y at D is 3 plus y at F over 2 is equal to 5 over 2. Alright, multiply by 2 on both sides of the equation, or just equate the numerator since the denominators are the same. So 3 plus y at F is equal to 5, right? And then subtract 3 from both sides of the equation. Y at F is equal to 2. Therefore, the coordinates of F are 1, 2. These are the coordinates of F. Determine angle EAD correct to 1 decimal place. So we have angle EAD, which is this angle here. So how can you find this angle, right? So we can find the angle of inclination of AC, which is this, and then we find the angle of inclination of AD, which is this, right? Meaning that to find angle EAD, we have to say the angle of inclination of AC minus the angle of inclination of AD. Okay, AD is better because we have the gradient of AD. Remember, we found that the gradient of AD is 1 over 2, just like that of BC. Okay, so that's the gradient of AD, but we need to find the gradient of AC. Let's start by doing that. Right, MAC is equal to y at C 7 minus y at A, which is 1, like that. And then x at C, which is 6, minus x at A, which is 4. Right, then the gradient is what? 6 over 2, which is 3. So tan CAD, okay, because this angle and this angle, they're just the same. So tan, I can say tan CAD. Okay, although CAD is it's just the same like the angle of inclination, that's why I'm using CAD. Okay, tan CAD is equal to 3, and then meaning that CAD is arctan 3, that must give you 71.6 degrees to 1 decimal place. We have the gradient of AD. Let's call this angle theta. So we can say tan theta is equal to 1 over 2. Then theta is equal to arctan 1 over 2. You get 26.6 degrees. Right. And then we said this angle here, we're going to say the 71.6 degrees minus the 26.6 degrees. Right. So therefore angle EAD is equal to 71.6 degrees minus 26.6 degrees, which is equal to 45 degrees. So this angle is 45 degrees. Right, 3, we are required to find the area of parallelogram ADEF, but we have this diagonal here. The diagonal divides the parallelogram into 2 equal parts. So if we can find the area of EAD, and then we can easily multiply it by 2 to get the area of the whole parallelogram. Right, what can we do here? We can find this length, we can find this distance here, and then we're going to use the area rule because we'll be having side, angle, side, and included angle. So let's find the distance AE and distance AD. Remember, we found the coordinates of E, isn't it? We say the coordinates of E are what? We say the coordinates of E are 5, 4. We did that in the previous question. Right, so we can find distance AE. So distance AE is equal to the square root of 5 minus 4 squared plus 4 minus 1 squared, which is equal to the square root of 10. Right, and then AD is equal to the square root of, we have the coordinates of D, remember, 8, 3. So we can say 8 minus 4 squared plus 3 minus 1 squared, which is 2 root 5. Okay, so now we can find the area of EAD. Area EAD will be equal to half, then root 10 times 2 root 5 times sine 45 degrees. And then what we get? We get that this is 5 units. We get that this is 5 units. Therefore, area of ADEF is equal to 2 times 5. 2 times 5 because we have this part and also this part. Okay, then this part is just same as that. So it's 2 times 5, which is 10 units.